So this is a presentation, but it's also a story. It's a story of a journey, like the title of the presentation says. Is a story of how a company called Osai Automation System decided to create another company called GreenTech, with a vision of bringing technology and automation to the recycling industry. It's a journey, and as every journey, we know where we come from, we know where we are, and we also know where we want to go. And fortunately, we know also how to get there. It's a journey about business. The story is about business, of course, but it's also a story about ethics and responsibility. The business pushes us to conquer a new market, the market of the recycling, but the ethic and responsibility that we feel is pushing us to do it in a more responsible way. And this is also the reason why Osai GreenTech is a benefit company. First, we take a look where we come from, so who we are. We are Osai Automation System, that is a solution provider, and Osai Automation System provides automatic machine, as the name of the company says. We do machine to assemble and test, and we work for medical application, electronic application, automotive application, and also semiconductor application. It's among the things we do, one of the things we do, and it's also the reason why we are here at this exhibition, we do system to assemble battery packs. So we put together cells to create a battery pack. And we work for the e-mobility in general, starting from the inverter and together with the semiconductor and also automation for batteries. In a more specific way, there are technologies that are that we normally provide that are more important than others about this story, because it's where the journey began some years ago. So we said that Osai is a solution provider. We have 32 years of experience, but in this slide you can see a selection of technology, and this selection of technology is the reason why now we are working for the recycling industry as well. We are familiar with PCB handling. We are familiar with laser soldering and welding, and we are familiar with the pick and place of electronic components. Because we have this technology in our portfolio, in 2015, when the Fraunhofer Institute was writing the proposal for a finance project, they saw on our website that we had a machine to solder the components using laser. They were calling us and saying if we could do exactly the opposite. So to start disassembling the components and to start desoldering the component using exactly the same machine. So disassembly instead of assembly, and separating instead of putting together parts. At the end, we said yes, of course, we participated to this project, and we were chosen to be part of the consortium with the main part of being in charge of developing the specific machine to desolder the components. We used the cherry picking approach with a laser desolder and with a sucking nozzle that was detaching and removing the components from the PCB board. There was a reason behind this. Indeed, there was a study that says that most of the value, or more than 90% of the value of a PCB board coming from the electronic waste, is in the component. So it would make a lot of sense to separate the component first. The demonstrator that we delivered and we installed by a recycling center, so a final user, was installed and was working perfectly. So the ADIR project at the end, and it was the end of 2019, was a success. We were really able to demonstrate what the ADIR project was in its meaning. But at the end of the project, with the project that was over, we had some information on our side, and the first information, it was that there was a lot of value in the electronic waste. It is something that we didn't know before. It is something that was a clear outcome of the project, It is something that was really analyzed with scientific methods to say how much was the value on the electronic boards. We knew that there was a lot of value to be extracted from the electronic boards. Another thing that we learned from the project was the need for automation in the recycling industry, the need for efficiency, the need for speed, the need for flexibility. And this was another thing that we had as a clear information, as a clear feedback and a clear outcome of the project. And then we learned another thing, that this kind of demonstrator was working, but was not the right solution for this kind of application. It was too slow, it was not flexible, and it was not efficient. And so it was more or less normal for us at the end of the project to try to think something new, something that was belonging to us, a new solution. And the new solution was born at the end of the other project, and it's called Reform. Reform is a plant, a solution, a machine that is capable to desolder the components from the electronic board coming from the e-waste, and to refine the precious metals within the same machine, within the same plant, in the same site. And this was really something revolutionary. We presented the solution in 2021 in a big exhibition that is every year here in Italy called Ecomondo. And the interest from the market was so promising and so immediate that we decided to create a new company 1 year later. And the new company is called Osai GreenTech. And the new company is a benefit company, because we wanted to give a message from the very beginning that at the end we want to do business in an ethical way. So we want to care about the environment, about the people, and about the territory where we are. The last part of this slide, as you can see here, is maybe the most important part of the story that we are telling, and is that we are going to deliver the first plant for treating the electronic boards and to refine precious metals within this year, within 2023. So it will be more or less 1 year from the foundation of Osai GreenTech, and we will be already installing a revolutionary machine by a final customer. Let's go a little bit deep to see what is Reform in detail. First of all, the idea that is behind everything. The idea is to find a way, find a solution to create an automation, a machine that is capable to transform the waste into precious metals. And this is what we did it at the end by this solution. So this is a rendering that shows more or less how the system works. And it is a system that is capable to be loaded with PCB boards that are coming from the electronic waste. And at the end of the first phase, you can have all the components of the board separated from the rest. There was a fundamental axiom that was driving us in designing this kind of machine solution. As what we said before, the value is in the components, so it makes a lot of sense to separate the components as a first thing. In fact, the plant has two main phases: the disassembly, the separation and selection of the electronic components, and the refining, that is a hydrometallurgic method to refine the precious metals contained into the electronic components that we just separated. We were lucky because during our journey we were meeting with another company with more or less the same vision as we have, but with a very interesting technology about hydrometallurgy. This company was the one that was helping us to do a complete integrated system to provide the real idea that is behind the project, that is to come from the waste to the refined metal. When we say refined metal, we are focusing basically in gold, silver, palladium, and copper. How is the system conceived? How is the plant conceived? First of all, you have to consider that it is a system designed by a company that is used to do automatic lines and full production lines every day. And so it is including a lot of main features that are very well appreciated by the market normally. Okay, so we were talking about the plant and how it is conceived. As we say, we try to include our experience and the main features that are normally very well appreciated by the market. And for example, the modularity and the scalability of a system like that. As you can see, the system is composed by different modules. We have two main modules that we call the base module, that are not optional, but they make the full system. The module one is loading of the PCB. This is something that is absolutely mandatory to have. And the module number two is the separation of the components from the PCB board. And this is the core of the whole plant. After this phase, the material takes two parallel paths. The first part and the most important one is about the components that are then detached from the PCB board, and the components can be treated in different ways. For sure, they can be grinded a little bit because we need the plastic to be broken to have the liquid to have the possibility to touch the metal and to attack the metal. There can be a mechanical selection, and there can also be an optical selection. But at the end, the components are divided in two or three categories that are useful then to make the refining process, the hydrometallurgy refining process, more efficient. There are other optional plants, optional modules that you can see here in this area, and they are regarding the PCB boards. So the PCB boards can just be unloaded into a box, and that's it. Or they can also be grinded and the copper separated. The PCB boards are basically epoxy resin, glass fiber, and copper. So once you have grinded it, it's pretty easy to separate the copper from the rest. But also this is a kind of modular approach, and is a module that you can update on the field. So if the final customer then decide to add this module in a second time, once the plant is already installed, it is something that is possible to do every moment without a long downtime of the plant. Here you can see the modularity a little bit better, only because the image is bigger. You can see the loading of PCB from bulk. So we can load from bulk, or we can load from big bag, whatever, doesn't matter. The thermal and the electronic component separation and detaching, this is the module number 2, and it's the most important module, I would say. And then you have the PCB path with the PCB grinding and the copper separation, and the components path, where we do a first light grinding, let me call it like that, and then an optional optical selection and separation into at least 2 or 3 fraction. Some of the features of the system that are really important, the productivity. This system can process up to 2 tons per day of PCB from the electronic waste, which are a value that makes sense if we contextualize later on in the context that we are working. The emissions in the atmosphere are almost negligible. Consider that the system is not incinerating anything. We work at very low temperature to detach the component. But being, in any case, a thermal process, even if it's a low temperature, there is an exhaust system. The exhaust system is fully comparable with the reflow oven that is normally used to solder the components on the top of the PCB board. So it's something absolutely normal to be installed in every kind of industrial environment. The energy required is very optimized. This was one of our target that we gave to ourselves at the beginning of the designing. And so the energy is really optimized, and it can be only electric energy. So we don't burn fossil fuels. And so the plant can potentially be supplied with only renewable energy. To give you an example, in our company, we have a photovoltaic system that would have the possibility to run up to 3 of this plant at the same time without no problem. Going back a little bit to see the process, how it is in a very, very schematic way. The automation separation on the left, where you obtain the separated components from the PCB board, and the refining of the precious metals from the electronic components. It is very interesting to see that this can be done on the same site with the same system, and it can be really completely automatic. And the combination of the two processes makes the proposal of this plant really unique in the market. And the efficiency is also very high. To supply a turnkey system like that, it offers the final customer a priceless added value that cannot be compared with any offer that you can currently find in the market. So it's a very, very unique solution and absolutely not comparable to anything else that you can find in the market. Just a quick look on the hydrometallurgic process. There is nothing really special to say except the fact that the standard hydrometallurgic process that is composed by a leaching, a concentration, and a metal recovery as a very, very standard hydrometallurgic process. In this case, is really optimized for the kind of fraction that the hydrometallurgic have to process. And this is the reason why the two parts of the plants are so important to be fully integrated, because the mechanical part is working for the hydrometallurgical part, and the hydrometallurgical part is designed to fit with the mechanical part 100%. There is another thing that it's very important to say is that the metal that we get at the end of the process is pure metal, is chemically pure metal. And if we see the example of the gold, for example, the gold is 24 carats gold. It's not coming exactly in ingot, as you can see here. This is a kind of marketing to make it more sexy, but it's coming in a kind of powder. It's gold powder, and it's immediately reusable for industry application and also for jewelry. So this thing to have the metals so pure and just refined on the same site is really unique, and it's really valuable. One of the reasons why the system is so efficient is that because if we process, for example, 2,000 kilograms, so 2 tons kilograms of PCB board, then only 40%, so 800 kilograms, are the valuable part of the waste. And so it makes sense as a first thing to separate before to go to the hydrometallurgy refining system. And what is the context in which we are moving and we are working? The context is that in Europe we are generating 12 million tons of electronic waste per year. And this value is growing 2 to 3% every year. We made a quick research, and there are more or less 340 recycling centers that are supposed then to manage this amount of waste. If you remember, we were talking about the 2 tons that the plant is capable to process every day. We made a rough calculation about coming from the 12 tons of electronic waste generated every day. We know that only the 2.5% average of the total weight are PCB boards, and so every single year you have 300,000 ton of PCB boards that you have to process. And if we consider 340 recycling center working 300 days per year, every recycling center must be, is a perspective, but must be capable to recycle 3 tons per day. So one plant per recycling center will not be enough if we will see the business in the next years. Of course, not all the electronic waste is processed in the correct way, but there is more awareness now about the importance of this thing. So we expect that the electronic waste that will be officially recycled will grow a lot in the next years. Also because we want to give the recycling center a better way to recycle the boards, and how we can do it by giving them plants and machines that they can manage, that they can afford first, and they can manage, where the return of investment is good, and where they can turn to a good business about avoiding to sell the boards abroad. This is the actual model that is applied. And the model now is that the recycling center are separating the electronic waste, and then the boards are sold abroad. By selling abroad the boards, there are a lot of disadvantages. Disadvantages in terms of value, because most of the values is transferred somewhere else. Disadvantages in terms of sustainability, because the waste is moving all around the world. Most of the cases, the boards are sold overseas, and then in most of the cases, the companies that are buying these boards are big smelters that are incinerating everything, trying to extract with a certain kind of efficiency the metals inside, burning fossil fuels and emitting in the atmosphere. So there are a lot of disadvantages in this business model. We want to change it a little bit by our technology. We think that we can do it. And our solution will allow to maintain the value on local scale. So changing to local scale will be the key. And there will be no environmental impact, but because the waste will not move anymore. There is no incineration in this technology, so we will not emit anything in the atmosphere, and we will not burn fossil fuels. And at the end of the story, this is what real circular economy is. It's a way to keep the value on the territory, on the place where the value is generated. And it's also the core concept of a benefit company like Osai GreenTech, by the way. This was a quick presentation about our company and the concept that are behind the starting of a new company like a benefit company. We really feel the responsibility about the technology that we hold, and we really feel that we can do something to make our environment better than it is now. Not only about electronic waste. That is one of our most important projects. But of course, we have the ambition and the duty to think about our future and also the growth of our company. We have a very precise idea about what we will do in the coming year. And this is, again, another result of our capacity to innovate and to do technology. There are many different applications that are, let me say, waiting for our technology. One of these applications are also related to other kind of devices that are not only electronic waste. But for example, we can see here, we have a very important hard disk drive recycling project. This is one of the input that we got from the market, because since 2021, when we started presenting our technology to a new industry, to a new recycling industry, we got a lot of stimuli from outside, and we got a lot of requests from different customers that were asking for different solutions, not only for electronic waste. Hard disk was one of that request, and the hard disk application is becoming reality now, because meanwhile it has also been founded by the EIT Raw Materials together with the European community. There is a lot of talks about how strategic is to manage the rare earth, and in the hard disk there are rare earth, also other elements, other materials that we can extract in a very I don't want to say easy, but at least efficient way from the hard disk drive. We have a concentration of neodymium in the permanent magnets that are inside of the hard disk drive. We have aluminum. We have a very interesting PCB board that we can then treat with the reform solution. And one of the most important things from looking at the project from a strategic point of view is that we are going to recycle 99% of the rare earth elements from treated waste at the end of this project, while now, at this moment in Europe, we are only recycling 1%. So it will be a huge improvement that goes in the direction of caring about how strategic are these kind of elements for our industry and for our life. Another very interesting project that we have is to recycle photovoltaic panels. The first panels are coming back from the installation after more or less 20 years since the first installation were done. And in most of the cases, the panels they share more or less the same technology and same form factor. And this is something that is enabling the use of automation, because we can really standardize a solution that is capable to manage more or less all the solar panels that are coming back from the field. We also have a personal, let me say, dream, that is not exactly a dream, but is to manage the second life also for the solar panel, to create some extreme low-cost installation after the disassembly from the original installations. As you can see here, the concept more or less is the same: fully complete automatic line that is capable to be loaded automatically, and that with different stations we are doing different operation on the panel in this case, exactly as it was for the hard disk for the other application. We are always talking about automation applied for the recycling industry. And then this is maybe the reason why we are here. We are talking about batteries. We have a lot of experience on the other side of the story about making, assembling, and creating battery packs starting from cell, because we do automation for that. We use laser to weld the cells into battery packs, and it's more or less automatic for us to start thinking about to do the opposite. There is not yet a massive flow of batteries coming from the field, but we expect that in maximum 5 years, we must have some automatic system to recycle the battery by disassembly. There is also a very interesting thing and approach that can be enabled by automation. That is the second life approach. Second life approach is very interesting because it's making also the batteries, the lithium-ion batteries especially, more sustainable because we can reuse it. By having an automatic system that is disassembling the batteries, we can easily check if the battery cells are, capable to be reused for a second life application. And there are many second use that we can do with those battery cells. That is, for example, the micro mobility. There is the home energy storage or power banks, where the efficiency is not the main problem, but maybe the cost, the price of the product can play a big role. So what we can offer at the end is a automatic system to disassemble the battery packs, coming from the automotive, but also coming from, let me say, home appliances. There are battery cells more or less standardized everywhere in the power tools and laptops. There are the same battery cells in the vacuum cleaner, the wireless vacuum cleaner. And it's just a question to extract them and to go back to the single cell. And then with the single cell, you can really decide to do whatever you want just by testing them and redirecting them in case of there's a possibility to second life is something that you decide by testing the cells, and then you can redirect the cells to a second life application or to a standard recycling phase. The second life is a very interesting approach because we can have immediately after the recycling plant another automatic plant that is then refabricating and rebuilding a new battery packs that can become a new standard for let me say low efficiency application like the ones that we described before. The integration of all these technologies is what it's really making the other value in this. And then last but not least, I think that we have a responsibility, and the responsibility it's inside of our knowledge, inside of our technology. We want to use this responsibility and this technology to do something ethics, something good. We would like to give our contribution to eco design approach. We are seeing in these years that eco design is key, especially for the recycling or to managing the end of life, and especially for battery packs. This is really important, and we have really all the information by seeing the fabrication and the automation to assembly, and also the recycling approach. We really have all the information to help in making more sustainable products and more recyclable products, and products that are already designed to manage the end of life. Well, this is another way to put our experience at the service of environment. I want to close an extreme synthesis about our concept. We want really to put automation as a key for a new recycling era. It will be a recycling era of efficiency and speed and technology. And talking about our journey, this is where we want to go.